So this video is a review of right triangle trigonometry. And to start, it has each of my three trig functions and it just wants me to fill in the blank. So I know that I have my mnemonic of SOHCAHTOA saying that sine is opposite over hypotenuse. So right here I'm missing the opposite over hypotenuse. And then cosine is adjacent over hypotenuse, so I'm missing the hypotenuse. And then tangent is opposite over adjacent, so opposite over adjacent, this is tangent. So these are very critical in solving the rest of the problems throughout this worksheet. So to start, I'm just going to show you one of each of these next types because it's really just a calculator thing. So if you have a scientific calculator, preferably, and you look right here to where my finger is pointing, there's a sine, cosine, and tangent right on the calculator. So that's all you're doing to do numbers 1 through 6 is entering it in your calculator. So you'll start by hitting sine. So once I push sine, that will pop up on my screen. And then I'll enter my 34. So sine of 34 looks like this. And then when I hit enter, it gives me 0.559. And this says to round to 2 decimal places, so I will say 0.56. So you can go ahead and go through and do the rest of those. And then starting on number 7, it's telling me the cosine of an angle is equal to 3 over 4. So in order to solve for this angle, I have to take the inverse cosine of each side. So then this cancels and theta is equal to the inverse cosine of 3 over 4. So again, it's those same buttons on your calculator, it's just right above them. So you're going to hit second first. So I'm going to hit second cosine, and it'll look like this. It'll have that cosine with a -1. And then enter my 3 divided by 4. So my calculator ends up just like this. And then hit enter. And it says to round to 2 decimal places, which is about 41.41 degrees. So both of these types of problems are very calculator-based problems. So I'm going to go ahead and let you calculate those so you can make sure you understand how your calculator works. And if you need to rewind and watch how I did it again, feel free to do so. And then numbers 13 and 14 is asking us to rewrite each equation using complements and the other trig function. So sine and cosine are what is called cofunctions. So if I wanted to write the cosine of 12 in sine version, I need to find the complement of 12. Complement just means that my two angles add to 90. So what plus 12 is 90 is basically what I'm looking for. So if I just do 90 minus 12, that gives me 78. So the cosine of 12 is equal to the sine of 78. And then it's that same idea on number 14. The sine of 43, well, that would be equal to the cosine, and then 90 minus 43 is 47. 15 and 16, I'm going to go ahead and use the Pythagorean theorem to do. So I'm going to start by drawing my triangle. So if I have a triangle here, oh, and it looks like I have a typo. This should say the tangent of x. So cosine of x, let's say this is my x, this is my right angle. So the cosine is equal to adjacent, so my adjacent is 4, over the hypotenuse, which is 5. So I can now use the Pythagorean theorem to find this third side. I'm going to go ahead and call it a. So I have a squared plus 4 squared equals 5 squared, which becomes a squared plus 16 equals 25. So I'm going to minus 16 from both sides, and a squared equals 9. So if I take the square root of both sides, a equals the square root of 9, which is 3. So once I have all three sides, then finding any other trig function is pretty straightforward. Tangent is opposite over adjacent. So if I look here, the opposite of x is 3, and adjacent to x is 4. So the next one is that same idea. I encourage you to pause the video and try it, but I will show you the setup. So I have my right triangle, this is x. This time I'm given the tangent, which is opposite over adjacent. I want to find that third side, so I'll use Pythagorean theorem to do so. We'll call it a again. So a squared equals 25 plus 144, which is 169. So if I square root both sides, a is 13. And sine is opposite over hypotenuse. So opposite is 12, hypotenuse is 13, so this is 12 over 13. Starting on number 17, we're looking for the missing sides in triangles. So if I look at 17, the biggest thing is figuring out which of those three trig functions do I use. So I'm going to start with number 17, and I'm looking at this 35-degree angle right here. And I say, okay, these are the only two sides that I care about, because this, I'm not trying to find it, I don't know what it is, so I'm not worried about that. So I'm going to worry about these two. And x is opposite 35, and 16 is the hypotenuse. So if I look at these three things, well, sine is the only one that has opposite and hypotenuse, so I'm going to have to use sine. So the sine of 35 degrees is equal to the opposite, which is x, over the hypotenuse, which is 16. So then to get x by itself, I'm going to multiply by 16 on both sides. So 16 times the sine of 35 is equal to x. And that I can just enter right into my calculator. So 16 times the sine of 35 is equal to about 9.2. So x is about 9.2. That's what this side length is. So let me show you that one more time, and then I'll let you try some on your own. So here I have this angle. I'm looking at my x and my 13, and x is opposite my 28-degree angle. 13 is adjacent. So the only one that has opposite and adjacent is tangent. So I have the tangent of 28 is equal to opposite, which is x, over adjacent, which is 13. So then I can multiply by 13 on both sides, and my 13's cancel. So x equals 13 times the tangent of 28. And if I enter that in my calculator, 13 times tangent of 28 equals about 6.9. So in this triangle, x is about 6.9. So I'm not going to take the time to go through all 6. I'm just going to do those 2. So if you are still confused when you're trying to do some of the other ones, go ahead and rewind the video and re-watch how I did those 2 and see if you can use that to help you do the other 4. I'm going to go ahead and move on to the next part where we're looking at finding missing angles. So 23, I have this x degrees angle here. So this is my angle. 14 is opposite that angle. 35 is the hypotenuse. So again, I'm going to go ahead and write my mnemonic up here. And it looks like the only one that has opposite and hypotenuse is sine. So the sine of this angle, the sine of x, is equal to the opposite over the hypotenuse. And now this, we actually solved a very similar one earlier in the review. We can take the inverse sine of both sides, and then this cancels. So x is equal to the inverse sine of 14 over 35, which you can enter right in your calculator. So I'm going to go ahead and do inverse sine 14 divided by 35 and hit enter. And that gives me about 23.6. So this is equal to about 23.6 degrees. Then I'll show you one more like that. So again, here's my angle. And my 2 is opposite my angle. 8.9 is adjacent to my angle. So the only one of these that has opposite and adjacent is tangent. So the tangent of x is equal to opposite, which is 2, over adjacent, which is 8.9. So then this time I'll take the inverse tangent of both sides. So these cancel. And x equals, in my calculator, the inverse tangent of 2 divided by 8.9, which comes out to be about 12.7. So this angle is 12.7 degrees. So the rest of these problems you will do in a very similar way. You're just going to have to see which of these trig functions you should use based on which sides you have. Number 29 actually starts to combine several things that we've learned this trimester. So it's asking us to find all missing side lengths and angles. So to start, I'm going to go ahead and just find this missing angle. I know that there's 180 degrees in a triangle, and this right angle right here is 90 degrees, and this one's 50 degrees. So if I do 180 minus 90 minus 50, this angle here is 40 degrees. And then I can use any trig function I want to try and find these two sides. So I'll just pick sine because that's the first one. So sine of 50 is equal to opposite over hypotenuse. So that would be 3 over y. So I'm going to go ahead and solve for y. And I guess I'm going to correct something I just said. You technically can't use any trig function. If you used cosine, that would be adjacent over hypotenuse, which would be x over y, and then you'd have two variables to solve for, which wouldn't really work. So if you pick a side, so I pick I'm solving for y, I can look and see this is opposite, this is hypotenuse, so I'm going to have to use sine. So then from here, I have to multiply by what's in the bottom, so I'm going to multiply by y on both sides. So I have y times the sine of 50 equals 3. So then to get y by itself, I'm going to divide by the sine of 50 on both sides. And y equals 3 divided by the sine of 50. So 3 divided by sine of 50 equals about 3.9. So this side length is about 3.9. So then I'm going to erase my work so that I can find x. And now I really can use any trig function because I know both of these sides, so any trig function would work. I'm going to go ahead and use, let's use the cosine. So the cosine of 50, excuse me, I'm still using that 50-degree angle. Cosine of 50 is equal to adjacent, which is x, over the hypotenuse, which is 3.9. So then to solve for x, I can just multiply by 3.9 on both sides. So 3.9 times the cosine of 50 comes out to be about 2.5. So this side's about 2.5. So I've now solved for all three sides and all three angles. I'm going to go ahead and let you do that on number 30. So I have time to do an example of a story problem. So my story problems examples ask us to draw a picture, formulate equation, and solve. That picture drawing is super important. So it says we have a 5.2 meter ladder. So here's my ladder. It's 5.2 meters. And it's leaning against a wall. So here's my wall. The bottom of the ladder is 1.9 meters from the wall. So this is 1.9. What angle does the ladder make with the ground? So I'm trying to find this angle right here. So this 1.9 is adjacent to my angle, and the 5.2 is the hypotenuse. So adjacent and hypotenuse is cosine. So the cosine of x is equal to adjacent over hypotenuse. And once I have that, I can just take the inverse cosine of each side. So x equals the inverse cosine of 1.9 divided by 5.2, which in my calculator comes out to be about 68.6 degrees. And it says to round to the nearest degrees, so that would be 69 degrees. I'm going to see if I can at least set up number 32 for you so you can solve that one as well. So Sierra is flying a kite. She has let out 55 feet of string. So here's my string. The angle of elevation is 35 degrees. How high above the ground is the kite? So I have opposite my angle and hypotenuse, which is sine. So the sine of 35 is equal to opposite over hypotenuse. So if you multiply both sides by 55, 55 times the sine of 35 is 31.5